Good afternoon. Campbell McCrary here, Amvest Capital in New York City live. Welcome to the Amvest Capital Inc. live webinar with E3 Metals Corp. E3 trades on the venture as ETMC, Echo Tango Mike Charlie, and as EEMMF on the OTC, bear with me, Echo Mike Foxtrot. And E3 Metals, E3 is one word there. I hope you enjoy today's program. It will also be available in replay mode. Feel free to chat in your questions in the question pane or email them, and we'll ask them in real time along with our other questions. Amvest is a New York-based specialist investment management and corporate finance firm focused solely on the natural resource sector. Recording of this call will be available in about an hour at amvestcapital.com/webinars. I should be able to remember that. And the all important disclaimer, this call is most definitely for informational purposes only. Very pleased to have us today Chris Dornbus, who is the president and director and CEO of the company. And Chris, I'm going to pass you the baton to present. You've got that. Okay, share your screen. Geologist by background. Chris is an expert in developing major projects in Canada and around the world. Strong technical background and has driven several projects through development stage to production. He was formerly the CEO and director of Revere Development Corp and vice president of exploration at MinQuest. Again, send in your questions and we'll ask them in real time, and we'll be happy to. And then at the end of all this, we'll be queuing you for feedback. It will be really cool to get your thoughts on the company, positive and negative and what have you. So Chris, I'm going to give you the floor. I see and hear you, and take your time. We'll get back to you on the other side.
Excellent. Thanks, Campbell, and thanks for having me on the program today. I know I've recognized a lot of familiar faces. I know there's a lot of some of our friends and shareholders on the call today looking for an update, as well as some new faces and names. So hopefully I won't bore too many of the people who know the story too much as we get through some of the good stuff and the update where we are today from the last time we did this, which was prior to Christmas. So a lot has happened with E3 Metals over the past 5 to 6 months. So really excited to be here to talk to you about that. This slide, I really like to start with this picture. We took this picture this past fall. This is our project site in South Central Alberta. And what I really like is that it demonstrates what E3's project is going to look like from the standpoint of an operating project. If you look around here, it's farmers' fields, there's power lines, there's a grid road every mile here. It's farmers' fields with farmers' houses. You can see farmers' houses littered throughout this area. But what you also see is oil and gas infrastructure absolutely everywhere. There are 8 oil and gas sites in this one picture alone. And what this really emphasizes is a couple of things. One, the social license that is so important to get a project from a development phase to a commercial phase is incredibly important to get and to have. And having a project that E3 Metals is going to develop that will operationally look exactly like an oil and gas project in Alberta means that that social license has been well established from the past 60 years of development of oil and gas in the province. And operationally, this all leads down to how E3's project is going to run. If you are producing oil in the province today, you drill a well, you produce a fluid from that well. Right now, if you're oil and gas, that's say 98% brine and 2% oil. You bring that to a central processing facility where you remove the oil from the brine and you put the brine back into the aquifer. That's the operational side of how oil and gas works in Alberta. E3's project will be the exact same. The only difference is we're not going to be chasing oil, so we'll be going to an aquifer and removing just 100% brine. The lithium is dissolved in that brine, but we'll still pump it from a well. We'll put in a pipeline short distance to a central processing facility where we'll remove lithium. And then we'll put that brine back in the aquifer. And what that means is that this project develops in much the same way and has a lot of efficiencies that we'll capitalize on as we grow. And so looking at where E3 is today, forward-looking statements, I'll be making them throughout. Please be mindful of that. And this will be part of the presentation that you'll have access to at the end of this, as well as on our website. You can read through the forward-looking statements. So E3 in November announced a positive preliminary economic assessment outlining a pre-tax value of $1.1 billion US, or an after-tax value of $820 million US, with a $600 million capital and one of the lowest operating costs out there for lithium hydroxide. And that is one of the key things about this project, is that we are on the bottom end of the cost curve for this project, and we aim to produce lithium hydroxide at battery grade. So that allows us to generate significant amounts of revenue, potential revenue as we get to the project into operations, and provides a really robust payback period of 3.4 years. So very strong economics, built on a very robust resource, 7th largest in the world, 7 million tons lithium carbonate equivalent in the ground, what E3 holds. I'll show you later, that's only about a third of the ground that we hold. The real linchpin to all of this, and what is creating a lot of value for E3 and will continue to drive E3 towards success, is the proprietary technology that we've developed. This is pretty unique for the world. There's not a lot of DLE technologies that are advanced as E3s. Because we've developed it specifically for the Leduc Aquifer here in Alberta, it has extremely high affinity for lithium, works very well specifically on our brines, which creates a lot of value for the company. So the PEA outlined an initial development plan of 20,000 tons per year of battery quality lithium hydroxide. That's what the economics are based on. The reality is that E3 can expand that production to over 150,000 tons, we believe. So huge green, blue sky potential for E3 to grow and become a major player in the lithium production world. And doing that hopefully with net zero carbon emissions. So all of this is backed on, obviously, the people who are building this are the people creating value for shareholders, and having a really strong team is fundamental to any company. So one of the things E3 has been doing is since our PEA has come out, and over the past 4 months, the company has raised equivalent about 14.3 million Canadian dollars. We've got almost $15 million in cash in the bank. And we recently were awarded, 2 days ago, we announced a $1.8 million grant from the Alberta government to help us pilot the technology. So that was recently announced. So well capitalized now to grow this company towards lithium production. And so we've been adding staff to the team. A couple of key members, Chris Ward and Peter, recently joined the team with Liz, Rowan, and John, that forming the base core of this, that are going to get us to commercial. And just an example, Chris Ward worked with me years ago back in Suncor. He's 10 years my senior. And we worked together on building the Fort Hills project, which is a $17 billion Canadian capital project. So an absolutely massive project here in Alberta. So understanding how to build these projects, and projects that are going to be way bigger than E3s is ever going to look at, means that we have the sort of robustness that is required to get a commercial project off the ground here. And Chris has taken something all the way from a pilot to a commercial and then operating. We've also been active at expanding the skill set on the board. So we've recently brought on John and Kevin Stashin. Kevin is an oil and gas executive, formerly the CEO of NAL Resources, which was purchased by another company here recently, and he's joined E3's board. The company that he worked for, NAL, had production in E3's area, so very familiar with how to operate companies in Alberta in this area. We also brought on recently Brad Wall. Brad was the former premier of Saskatchewan, so very tied into the government and the necessary requirements that we're going to have to go to get permits to get this project operational. Instead of talking about the lithium market, I just wanted to bring up an example of where the market is going. So if you're listening to this presentation, you're probably already familiar with the drive for lithium is in demand, and that a lot of people talk about the supply-demand gap, but the future of lithium in the EV world, I think, is only going to get stronger. And I wanted to point out QuantumScape. I listened to their talk a couple of weeks ago. They have a joint venture with Volkswagen to build a gigafactory in Europe, producing, I think they said, don't quote me, this 20 gigawatts of battery power capacity in solid state. And one of the things about solid state is that they don't just use, they use a solid state cathode, which is where the solid state name comes from. But they also, in QuantumScape's case, use a lithium metal they don't use an anode, but they use lithium metal where the anode would be. And that provides a much higher energy dense battery, a much safer battery, but also uses more lithium. And I think that this is where the future is going to go. So lithium being a key component of batteries now and even more important into the future. This is some details on the PEA. It's in the presentation. I'm not going to take you through it in too much detail. I've already pointed out some of the key factors, but it is for your reference. How the PEA works, how our project, the PEA has outlined our project will work. We're going to have a very small footprint. So we have a couple of well pads where we drill a number of wells from each pad. We accumulate that into a pipeline that runs about 15 kilometers to a central facility. At that facility, we run the lithium extraction portion, which is our DLE. We then make a lithium hydroxide is the goal right now by putting it through a purification step, and then we produce the battery grade product. A couple of the key pieces of this, it's a very small footprint. We also are 100% disposal of the brine back into the aquifer. So we don't create tailings ponds or open pit mines or those big salars that are in South America. Everything is very, very centralized. Because the DLE process is a chemical process, not an evaporative process, the footprint of that is also very, very small. So when you look at this from an ESG perspective, inherent to DLE, and most DLE companies can claim this, no tailings. We specifically don't use fresh water in our process. We recycle our water, and we only use 3% of the land. So that's just inherent to the process. We're not doing anything special there. The one thing that we want to add into the fold here from the ESG side of things is zero carbon. So we want to sequester the carbon that we generate. So how this is going to work is that a percentage of our power we're aiming to come from wind. So we've got a big wind farm on our property, and if you look at some of the pictures on our website, you'll see that wind farm. So that can add some power to this project. It's 80 meg, so it's intermittent, so you add that into the fold. But the base load will be provided by natural gas. And 3% of the 3% of the exhaust that comes out of a natural gas power plant is CO2. Alberta has developed sequestration technology that takes that exhaust gas, that CO2 out of the exhaust gas and disposes of it into the aquifer. And because we have the brine stream already going back into the aquifer, we have a disposal place for that CO2. This technology is being deployed by a company called Enhanced Energy. You can check them out. They're local to us. They're about 10, 15 kilometers away, and they do this exact same thing into the same aquifer. So already proven tech, we're just going to deploy it in Alberta. Looking at the technology really quick, engineered for purity. So we remove over 99% of the impurities. We end up with a concentrate solution that's between 80 and 95% lithium. So we already are getting to that purity level. You need sort of the base parameters 99.5% pure. So we're 80 to 95. We're already getting very close, and we concentrate it from the 80-ish average concentration in the reservoir to up to over 5,000. And that's the real heart of this. And that allows us to produce the battery quality product, allows us to do it very efficiently, and it happens very quickly, and it's very efficient. It has a high affinity for lithium as we extract that lithium out of the brine. So all of that comes together and adds a huge amount of robustness to the economics that we've outlined in the PEA. And a short amount on the aquifer and the resource. So this is the Leduc in Alberta, was discovered by ExxonMobil in 1947. It used to produce oil in certain places, not very huge amounts, but from an oil and gas perspective is a huge and prolific producer of fluids. And that's the real advantage here, is that the Leduc is well known to have the ability to produce huge amounts of fluids from it. And that is what the project in the lithium space requires, because you have to produce those fluids out of an aquifer, regardless of who you are, if you're in the brine space, to get the lithium out of it. And so for us, this aquifer is the key heart of what we're developing here in Alberta. We've developed 7 million tons. If you look at the blue shaded areas on this map, those are where the resource areas are. The white outline is our permit ground. So we only have resources of about 1/3 of the permit ground that we hold, which covers the aquifer itself. So the ability to expand the resources is also here. We also have not put any resources together over the Nisku, which also is lithium bearing. So huge opportunity for us to both expand the resource as required as the market grows, but also continually expand the production year over year as we grow this and as the market grows to become a major producer of lithium products into the battery market. So a couple slides here on Alberta. I've already sort of talked about it, so you guys can use these as reference. You know, DLE is somewhat of a new technology that's come out. It's becoming more and more proven. Standard Lithium is a good example of a company that is probably the most advanced towards commercial in the DLE space. Looking at a comparison of them to us, a couple of key points here. They have a bit of a smaller resource, and they're joint venturing into Lanxess's project. So right now, Standard owns about 30% of that project, and they can joint venture into about 40%, where E3 owns 100% of our resource, and it really does separate us out in terms of the long-term value. But right now, because Standard is further advanced than us, you know, they have piloted their process, and they're in the process of demonstrating the production of lithium carbonate at battery grade, and they're doing a very good job at that. From what I've seen from their public disclosure, they have a 3.5 times value up on us. So I think what this demonstrates is the runway that E3 has over the next 12 months. You know, considering E3 is now fully funded to get to that pilot stage and to get this technology proven out, that's really the big difference from my perspective of where Standard is versus where E3 is. So I think it gives us a really good runway to see E3 potentially obtain a similar valuation to Standard as we go. So that brings us to where E3 is at right now in terms of our development plan. So breaks into 3 pieces. Number 1 is proving out this technology in a pilot. Again, that grant from Alberta Innovates, you know, they're backing it now with $1.8 million as a grant fund to get us piloted, and that happens in 2 pieces. So we're in the process right now of finalizing the development plans, and we'll be building a prototype in the lab here very shortly, and that provides a nice design basis for the pilot. We aim to have that pilot hopefully in construction by the end of this year at the latest, and then operating early next. So that's the goal for us on the DLE side. In terms of the aquifer, it's very well understood, but one of the things we need to do is a production test to upgrade the resource to measured and indicated. So that's the goal for us right now. And we believe that there's potentially higher grade lithium in some of the other areas in the aquifer, and we're going to demonstrate that hopefully as well with that production test. And the last piece of this is, you know, demonstrating on a large scale the production of lithium hydroxide at battery grade. And that is something that Rowan is working on adamantly right now. It's not new technology. We're just borrowing largely from the hard rock side of things. They've developed processes that take a similar concentrate solution that they make out of the hard rock mine and electrolyze that into lithium hydroxide, which is the sort of going method right now. And so we're working on similar tech development and testing various different vendors is the plan for this year to nail down the process that we plan to use for a commercial plant. So all of that is basically the optionality studies that are required to complete the pre-feasibility study that we aim to have out mid next year. And that will have the reserve booked in it, obviously, as well as a detailed plan down to like the plus minus 20% of what this project's going to cost to build. So the next level from the PEA where we're at right now. And the longer term goal for this company is lithium hydroxide produced in somewhere in the 2024 to 2025 range. So over the next year, we're developing all the plans and engineering to get the pre-feasibility study done. We complete that mid next year along with the pilot and the upgrade to M&I, and then we spend another year doing detailed engineering design. And while we start to look for the project finance, which will likely be a combination of offtake agreements and debt with probably a bit of equity to get us to a construction start and then build this project. And how that breaks out is it's actually quite about a third in terms of that 600 million. So 1/3 are wells and the pipeline, 1/3 is the DLE and pre-treatment, and about the other third is the polishing and lithium hydroxide production. So it also allows us the ability to ramp up. So we don't necessarily have to start at 20,000 tons. We can also start at somewhere 5 or 10, and that not quite, but that construction capital does scale down almost linearly. So you can divide that by the production number to get something. So it gives us the opportunity, if we need to start a bit smaller and have a bit of a smaller burn at the beginning. So lots of optionality as we grow this project, and that all gets outlined in the PFS as we work on that in the next 12 months. So right now, trading at around the $3 mark gives us a market cap of about $155 million Canadian, about 125 US, $14.8 million in the bank, plus the Alberta Innovate grant of $1.8 million. So that wraps me up. So Campbell, if there's any questions, I'd love to talk.
Sure, I've had a whole bunch come in, and we have some ourselves, and joined by my colleagues here. Right-of-way issues with the proposed 15K pipeline. Is that an issue or not?
It's something that we don't have the right-of-way, but the other side of this is that the PA does not contemplate the exact location of that pipeline. That's the pre-feasibility study. So over the next 12 months, 100%, one of the key goals for Liz and what she's working on right now is we define where the pipeline is going to go, and then the permits get applied for that. As I mentioned, if you look at any of these pictures of Alberta, there's pipelines underneath all of this ground. And if I showed you a map of pipelines in Alberta, it just becomes colored with that color because there's so many pipelines that run under all of these, connecting all the oil and gas infrastructure. So yes, it's still required, but I think that it is a very low risk activity considering the social license for these and the permitting regime in Alberta is already set up for this exact activity.
Just jumping around a bit, US listing, would you contemplate a higher OTC listing? And then someone mentioned a proper NASDAQ listing, all in due time, but while we're on the subject.
Yeah, I think you're absolutely right, Campbell, all in due time. It is something that we're definitely eyes are on. You know, it benefits us, I think, in the long term, especially when we're looking at, you know, maturing this company from where we are today to a producer. A full US listing makes a lot of sense for the company. There's no confirmed plans to do that as of now, but it's definitely in the strategy.
Okay. I'm not sure what this person refers to, but can you talk about the selective affinity resin, and is it organic, and what kind of pressures can it withstand without getting squashed into a pancake? So what are we talking about? Yeah.
Yeah, I'm not going to get into the details of what it's made out of. That is very proprietary. But we do test it at the pressure that we anticipate running it at, and there's no issues with it in that sense. The affinity for lithium is one of the key attributes. And the one way to demonstrate that is in the kinetics, so how long it takes to extract the lithium out of the brine. And that we published, I think, April 2019 or March 2019. So you can check out that news announcement. We talked about the kinetics, or it might have been actually April 2020. It was 2020. So you can look at that announcement, and we talk about how we get over 90% recovery in 15 minutes. And that's really speaking to the affinity, how fast the lithium bonds to this material. So yeah, it's extremely well is the answer.
Huh? Can you elaborate on how do you envision the transportation method of delivering your product, rail, heavy haul trucking?
Yeah. So there are several main trunk line rail lines that run through the property. The big one between Calgary and Edmonton. There's lots of spur lines off that, and then that links up to the Trans-Canada line that runs coast to coast. So the most likely transportation method is going to be CCAN. It'll be packed in some sort of like plastic lined cardboard drum, and as lithium hydroxide monohydrate, packed into a CCAN and shipped to the customer on rail, and then shipped most likely, because at the present time, the market for this is overseas. But I would love to see that change. I would love to see us build batteries in Canada, and I'd love to see North America build that value chain. I think everyone's aiming for the same as well. So hopefully that stays on rail all the way to its destination.
At what stage is surface DLE pilot extraction process?
Yeah, I mean, it's in progress. The pilot project is in progress right now. We're basically just designing what the field's going to look like, and then building it smaller scale in the lab to make sure we've got all the kinks worked out. And then whatever that ends up being at the end of the day will go to a fabrication company that design to get built. So we're at that sort of initial design phases of the pilot itself. And that's why, the prototype we want to have operational in the next 6 to 8 months, and then that's the kickstart of the field pilot construction. So 12 months we want to be operating that here in Alberta.
Sort of timeline to when you might be able to confirm partners and offtakes and all that. Weeks, months, years? What do you say?
Yeah, I think it depends on what level and what type of agreement. A true binding offtake agreement with real terms will not happen for us, or probably any company really, until after the pre-fees and we've demonstrated that we can deliver the quality of product to them that they require. And so, but I think that in terms of the next level down from those, and just to be clear, those are the types of agreements where they would come with potentially a cash component. We have locked in terms, and that's what we would use to facilitate any debt financing to construct the project. There's a timing for us as well, like giving those away too soon, you end up committing to timeframes, and we want to be certain we're going to meet any timeframes, any hurdles, because you end up getting penalized if you don't. So there's a time and a place for those types of agreements, and that's generally, it'll be 2022 to 2023. But the next level down is obviously something that we are in discussions with various different partners, anyone from a development partner to a potential off-taker that wouldn't necessarily sign a binding offtake agreement, but the next level down from that, which is like some sort of investment agreement or something. And we do have a couple of non-binding offtake agreements with 2 companies that are currently manufacturing batteries today. And so, those are at this point relationship building documents. They haven't been publicly announced as to who they are, but very important to build relationships with these companies early on, and we're focusing on that right now.
Thank you.
Yeah, thanks for the presentation, Chris. So the plans for this year, the production well testing and the resource upgrade, are you going to be conducting any drilling here? Or if you could talk about what goes through the process for the resource upgrade?
Yeah, the goal right now is no drilling required. So Alberta's facing a challenge right now because a lot of companies are uneconomic and have gone into receivership. And there's something called the Orphan Well Fund, which is a bunch of cash that's supporting a bunch of wells that get orphaned by companies who have unfortunately gone insolvent. So there's a big problem in Alberta and a bunch of infrastructure that's out there. And on the other side of the fence, there's also a lot of infrastructure that companies still own that's not economic. So our goal right now is to, and we're working with a bunch of operators that have been very amenable to this, and you know, everyone understands what's going on in Alberta, and we're all working together to look at repurposing these wells to lithium producers. And so the goal is to just work with these companies to get access to their wells, either by them doing the work for us or by us taking the well on and doing the work ourselves, to do all the development work we need to. In a commercial scenario, we will drill our own wells most likely, at least in the production sense. We might repurpose the disposals because they're mostly in the oil and gas area where we don't necessarily want to be producing lithium from. But from a development standpoint, the goal here is no new drilling. And we're pretty certain we're going to be able to accomplish that with these operators and testing existing infrastructure. It makes the most sense.
Yeah, gotcha. And then on the production well testing, you know, what would be a successful outcome in your mind? Like, what would you be looking for before you'd be comfortable ticking that box to move on to the next stage of development timeline?
Right now, the hurdle for us to do a production test is just time. We're just working through the logistics of it, planning, getting costs in line, getting contractors lined up. All of that work has started. So it's just a matter of how long all that takes to get the work done, and then we're going to get out there and do the test. So my hope is in the next 6 months, we'll have that test complete. But a lot of this is out of our hands in terms of the timing, but I think before the summer's over, we'll have this test running.
And then what about the flow rates? What type of rates are you trying to achieve?
So the PEA contemplated 3,300 cubic meters of brine per well on a daily basis, and that is what we're aiming to demonstrate. That's the key purpose of this test, is really to verify that number by actually putting that pump down that we spec'd out. So we actually spec'd out a Baker Hughes pump that we believe can deliver this, and that's how we base the PEA on, is that pump and the power draw for that pump and the cost to buy it. So we'll take that one or a very similar one, and we'll put it down one of these wells or a couple of these wells and run it and verify that it can deliver that. And you monitor other wells in the area to see what the response is. And that gives you all of the data you need to develop this. And it's more than you need for an M&I, but it's what you need for the production to determine internally what we need to do to produce at a commercial level. So it's one step beyond the M&I requirement, but it gives us all the information, therefore we need to do the M&I.
Yeah. And for people that are used to seeing, you know, the brine operations in the lithium triangle, or, you know, in the deserts in the US, you know, how can you leverage off the knowledge in the area you're in from the oil industry and, you know, their past mistakes and knowledge and operations? Like, what's the kind of main difference and positives for you?
I mean, 260 active or suspended wells in the area, 60 years of production out of the aquifer for oil. It's at the end of its oil life cycle. Like, there's not a lot of oil left. Most of the producers have, you know, closed in production. That's why some of these wells are still available. We have 60 years of production data out of the aquifer. We have people who've done all sorts of different production and injection tests for their own purposes in this aquifer. All of that data is out there. We've gotten some of it. We're working on getting more of it. And you would have seen one of the staff we brought in, Peter. That's his job, and he's been with the company for a month and a half. He comes from oil and gas background, 25 years doing this exact work in Alberta, developing for oil and gas, and that skill set's directly applicable to what we're doing because it's the same aquifer, it's the same production. If you're producing oil, you're producing 98% brines anyway, so all of that transfers directly over. So he's working that plan right now, and Yeah, so it's pretty advanced. Like the risk around the aquifer and it being able to produce the fluids is very, very low relative to any other project that's out there, I would say.
That's good. And then on the flow sheet and operations, are you using any reagents that would cause any environmental issues, and like what other chemicals do you use, and what might the supply chain availability for those chemicals and reagents be for you?
Yeah, we do use some reagents. What they actually are, I'm not going to outline because it does fall into that proprietary basket, but a couple things to note. One is that this aquifer is 2.5 kilometers deep. It's non-potable. It's 200,000 TDS, which means that it's 20% salts. So it's not a source of anything for human consumption or human use in any way, shape, or form. And the Leduc has also been used as a disposal area for other things. And what that means to the company is that, the regulator has a classification for this fluid, and it provides a range of what can go into it in terms of the element basis and the pH and all those different things. And as long as you stay within that range, you can use it as a disposal zone. And that obviously requires the right permit, but that permit can be applied for and can be obtained. So from our perspective, nothing that we would need to get rid of can't be disposed of into this aquifer. So from that perspective, there's going to be a very, very minor amount of waste that we would generate, and it would be mainly like, you talk about things like the garbage that the people on the facility start to make. Like that's at the level that we're talking about. It's a very, very minor amount of surface disposal that we would require.
Yep. And then on kind of construction timeline, like if let's assume fast forward, you've done your final feasibility study, offtakes, you've got the cash, you're starting tomorrow. How long before, what are the stages in construction, and when you'd be selling your first, piece of production?
Yeah, our estimate is about a year to do all the drilling and install the pipeline. And I'm pretty certain, based on the design that we have at the moment, that you could have the facility built in that year as well. But you always add a bit of conservativeness to this. So let's say 18 months for the facility. I think that the drilling is very well understood, so you could probably lock that time in within a month. And then I would say 18 months, for the construction of the plant. Looking at it from the permitting perspective, though, I think that's where the time frame is really going to be enhanced. A permit for a well license in Alberta, which is attuned to the mining license, right? It's the license that gives us the ability to produce the resource. Right now, if you're oil and gas, they're 4 to 8 weeks for approvals. So if you compare that to anywhere else in the world, it's so much shorter. And that's one of the biggest things that usually projects get, from my experience anyway, having permitted mines. That's one of the big things that gets pushed out, that time frame, is how long you have to do consultation and all of that sort of stuff can be very onerous. And for Alberta, because this is a very sort of standardized, especially in the wells side of things and the pipeline, it's very, very standard operation for Alberta. So there obviously is a permitting time frame. There obviously is a consultation that we will do with the locals and the farmers in the area and the First Nations, and all of that will happen. But it's the stock standard process that's applied every day in Alberta.
Yeah, that's definitely interesting. Something I'd overlooked, that production well timeline. I'll pass it on to Artie.
Thank you. Regarding pumping back this solution after recovering the lithium to the ground again, do you think it will create some challenges in terms of mining?
No. So the aquifer that we're taking this brine out of and then eventually putting it back down into is a confined aquifer that's about 2.5 kilometers deep. You know, it's well understood, it's been drilled and produced from for, like I said, 60 to 70 years, depending where you are in it. So, you know, the ability for us to remove the fluids is well understood. The ability for us to put the fluids back down. I mean, the oil and gas companies are doing that whole process today, so we can actually point you to 14 different operators that have small amounts of production in this aquifer and show you that they're actually doing that today. And because it's not a mine, right? It is in this sense much more an oil and gas project because we're moving fluids around through wells and pipes. It's a very low impact, right? Even on the surface side of things, you know, the well pad is 200 meters by 200 meters. And there are 5 of them. So that's the main footprint, and then you have the process facility, but the mine footprint is 5 200 meter by 200 meter pads. So it's pretty minimal.
Thank you. And what will be the technical capabilities of this pilot plant you are working on?
Yeah, I think that we're looking at a scaled down version of what will look like as a commercial operation. The way that I envisage it, and you know, Rowan and Chris are the 2 folks on the company that are managing this. The conversations that I've had with them is, imagine an ion exchange column. It will have a certain capacity to extract a certain amount of lithium on a daily, yearly basis, right? So you'll have a tank, it'll be full of the material that we're developing, you'll flow the brine through it, it'll have an extraction capacity, and you'll cycle back and forth, you wash the lithium off, and then you cycle the brine through it again, you extract more lithium off, then you wash the lithium off, and you just cycle back and forth. And so that individual tank will be able to extract X amount of lithium based on the size. And in a commercial scenario, you'll have a certain number of those to match your commercial production. And so the goal for the pilot is to put one of those full-size commercial columns in the field next year. So what that means is that we are actually, although it's a much smaller scale, the inner workings will be very similar to what it will look like on a commercial level. And I think that will give us a lot of certainty around going from scaling from a pilot size to a commercial size, because you're just building more of those same tanks that operated in the pilot. So it's our way to significantly reduce the scale risk that every project, regardless of who you are and how old your technology is, you go through that same scale risk.
Thank you. Campbell?
We've got a bunch of questions I want to kind of motor through, so answer efficiently.
Rapid fire?
Chris. Yeah, okay. Why produce hydroxide over carbonate? What would the capital requirements look like to scale up beyond the initial 20,000 ton annual production?
Okay, so right now we are going hydroxide because all of the high energy dense batteries need hydroxide because of the temperature you have to make them at. And it looks like the hydroxide market is going to be the one that's really going to grow over the next 5 to 10 years. And the initial production will likely go hydroxide because of that. As we scale, and this is to your other part of the question, there's no reason why we can't make carbonate or lithium metal or other products like lithium sulfate or lithium sulfide. So, and when you look at the evolution of the battery technology, the dominant product on the market today is likely going to be hydroxide in the short term. In the long term, we'll be able to bring on other types of products very easily because our concentrated solution can be made into any of the products.
Okay. Are there any approximate figures on what the effects on opex would be if it were possible to expand to 150,000 tons per year in the future? In the PEA, 20,000 tons per year was currently planned.
Yeah. So yeah, I mean, it's the general rule of thumb is 6/10 to grow production. So you know, because you already have a lot of the cost nailed down, so you times by basically 60% to get to the expanded production on a ratio basis. But the wells and the pipeline are 1-to-1. If you want to increase your production by double, you need double the amount of wells. right? So that doesn't follow that rule. That'll be a very linear, double your production, you double the cost there. But the production facility will likely be built, the first one, the building itself, to handle 50,000 tons. And because everything is modular, like even the electrolysis cells, you don't just build a bigger one, you add more of the same size one. Same with the DLE side of things, you just add more tanks to expand your capacity. So we would build the facility big enough to house it, but we would put in a smaller scale production, 20,000 tons to start. And then you just add those modules as you need them. So, it's not going to be double the production, but it obviously does cost more money to put more production in the stream.
How would scaling work for DLE with respect to cost? If the project requires about $600 million for 20,000 tons of lithium hydroxide per annual, would it take maybe 1.2 billion US dollars for 40,000 tons of lithium hydroxide?
Yeah, I don't think it will scale double. It's not linear. Some pieces of it are, some pieces aren't. The DLE specifically, we're going to aim for hub and spoke, right? So we'll likely have a production area over here and over here and over here making the concentrate, and then we'll ship the concentrate through a very small pipeline to the central facility that we build first off. So that's why I'm saying that facility will likely be built to handle the total production we aim for that particular area, which I think in the Clearwater, the aim right now is 50,000 tons a year from the Clearwater. So we'll start at 20, but we'll be able to expand production of the hydroxide plant quite easily, and then we'll just bring on hub and spoke operations for the DLE concentrate and the brine production.
What is the estimated temperature of the brine at surface?
80 degrees Celsius.
What other materials, metals are recoverable from the brine? Are there additional revenue streams available?
I definitely think so. We're talking to some companies that make calcium and magnesium products to explore those opportunities right now. The reality is that nothing makes the same value as lithium. The next thing in the brine that makes money is strontium sulfate, and it sells for like $1,000 a ton, where we're projecting lithium to be 14, or depending who you talk to, maybe more, 1,000 per ton US. So that's a whole order of magnitude smaller value-wise. So definitely, because you're already paying for the brine to be brought to surface and it's got stuff in it, there's value there. But the focus for us has been lithium. But this year, again, one of the jobs Rowan has is developing that potential process streams.
Are you considering licensing your technology?
Yes, we are in discussions to license the technology. No plans as of yet on how and what we're going to do there, but it is definitely something we're discussing. The goal right now is to get the prototype running and operational, because the big thing that does for us is gives us the opportunity to test other people's brines in a real life scenario, scaled down version of what that machine will look like. So that's sort of the goal right now, but definitely something that we're considering. First priority to the E3's project.
What is the current continuous throughput rate that you have achieved at the lab?
It's in, I would say, like the liter scale for sure. So that the whole goal of the prototype, when you scale, you scale in like it's punctuated, right? So you do a lot of work at one scale, and then you grow to a big scale and you build a machine. And so that's what the prototype is that next scale, and that's what we're working on right now. So, and that'll be probably cubes.
You cannot mine and process lithium within your net zero template. Would your supply be penalized in the case of price by customers?
So penalized if we don't meet a zero carbon hurdle?
I guess what would happen, suppose?
Yeah. Right now, I'm not aware of anyone who's getting paid more or less on their carbon footprint. However, I firmly believe that this is going to be something that's going to be important. Right now, I think purchasers of the lithium are not spoiled for choice. There's not a lot of opportunities to get lithium that's in production today. But in 5 years from now, all of us incumbents that are hoping to have lithium production should have our lithium production out and it'll give a lot more optionality to that. And you know, there is no zero carbon option on the table today. So I don't know how that'll be handled, but my guess is that considering that the OEMs are very concerned about the impact of their product and taxed in Europe specifically on the total impact, not just the CO2 output from the exhaust pipe, but also the CO2 input to the materials, that it will be an important factor. And likely there will be a payment scale that it'll be based on, but that is not in place as far as I know.
Want to thank everyone for tuning in. Didn't get to everyone's questions, and really we could have been here another hour talking about the lithium market itself. So kind of steered clear of that. But I encourage you all to reach out to the company for more insight there, or just email me any more questions you have, and I'll make sure they get into their hands and you get a reply. So I'll sort of ask the last question, sort of why by now? So that it really involves, if you can kind of summarize your catalysts and deliverables, both promises and aspirations, and then 6, 12, 18 months, then we'll close.
Awesome.
2
yeah,
minutes.
I think, yeah, thanks, Campbell. I think that, you know, when you look at our development plan that we have in front of us for the next 12, 18 months, that time frame into summer next year, the biggest milestones the company has achieved are about to be achieved in the next 12 months. So there are some major things on this list that, you know, piloting the DLE technology in Alberta. Just imagine a company that has one of the leading DLE technologies and has 7 million tons to build projects around. You know, the value of that company would be much higher than the value of E3 today. And obviously it's the big critical hurdle that we are working towards demonstrating to the market so that, you know, we can move to the next stage, which is commercializing. So, but then even something like an M&I resource, it'll be the first real brine M in the DLE space, measured resource, and number 2 for the indicated side, but definitely in Canada and in these aquifers. So I think that that's a huge movement for the company, and booking that reserve on that through the pre-feasibility study also is going to have a huge catalyst for us. And nothing creates value to E3 and to the the company and obviously our shareholders than making lithium hydroxide and selling that. So commercializing this project is obviously the #1 goal for the company, to start making revenue, and demonstrating that we can make the product that's going to generate that revenue is also a massive milestone. So those 3 things are all what we're working on today, with goals of having them all done within the next 12 to 18 months. So and some of them in the short term, 6 months, 6 to 12 months. So especially the M&I upgrade is going to be in the 6 to 12 month range, and potentially even the lithium hydroxide. So I think that, when you're looking at E3 as an investment and why you would invest in E3 today, it's that we're just getting started. When you look at the catalyst of someone like a Standard Lithium and the value that they have, we are just on the path to sort of achieve similar values to that. And we're fully funded now to accomplish all these goals. So no more dilution to get to our goals.
Excellent. Thank you, everyone. And please share your feedback. And thanks, Chris. Appreciate it.
Yeah, absolutely. Reach out to us. Jennifer's on the call today as well. You can reach her at investor@e3metalscorp.com. If there's any questions, her and I definitely answer all of them personally between the 2 of us. So definitely keep in touch.
Thank you. Good day.
Thanks, guys.
Thanks.